Awesome. So hello, welcome to the 1 week delay of our professional data engineer study group. Yay! Um, for those of you that are just joining us for the first time, welcome. Thanks. Don't worry about that. We've met a couple times. This is basically it's a pretty informal study group that's geared towards the Google Professional Data Engineer exam. So we have gone through quite a lot of content, and today will mostly be kind of going over the exam, reviewing kind of the general topic matter of the exam. I have a bunch of, I don't know how many, maybe up to 10. I don't know if I have quite about 10 practice questions that I've put that I'll share in a Slido that we can interactively work through. And then we'll kind of go through some housekeeping questions, all that kind of stuff. So this is pretty informal. I try to, answer questions based on my own knowledge. I don't know all the things. I'm taking the exam as well. So this whole journey has been selfishly, I was wanting to take the exam, and it's much better to be kind of doing this with other people. So, and I got pulled into being a GDG leader in Atlanta, and felt that doing a virtual program would be really kind of better, whether people were from Atlanta or for elsewhere, because Atlanta is very big anyway. So we might as well just do it virtually so then everybody can join. Yes. And so Meredith, one of our regulars, she leads the GDG program in Bloomington, Indiana.
Illinois.
I'm not making that up. What? Am
It's
I correct?
Illinois. There,
Jesus
there are
Christ.
many
I'm sorry.
Bloomingtons, but no, it's
Okay. There is a
actually
Bloomington,
next to
Indiana.
Illinois.
I'm very sorry. I
Yep.
apologize. Okay. So in Illinois, and she will be leading, her group will be leading a virtual study program for the machine learning program, which I plan to kind of join in on that as well. There's an info session coming up. When does that officially start, Meredith?
The info session is tomorrow, and then the first session of the actual group is going to be on Tuesday, May 23rd. So I guess, is that just next week? Wow. Yeah, I guess it's just
It
next
is.
week.
It is.
Yeah. But we're kind of doing a little bit of a soft start because I've been to enough of these groups that it seems like people could use a little bit more time to get rolling at the beginning. Um, so there won't be any homework for the very first session.
Yeah, I would agree. If I were to do that differently, I think I saw that you have like a session 0 in addition to the info session. So you're doing 7 sessions?
Right. Yeah.
Cool. That makes sense. Yeah. So this has all been a learning process.
Yes,
So
yes,
that's
Rajesh.
awesome.
And I have
Um,
benefited
Just
from
wanted
that. So thank you.
just wanted
yeah.
to add,
Yeah. Pradeep, are
Meredith,
you trying to ask a
Meredith.
question?
No, no, I'm just adding what
Pradeep?
you both were talking. Am I audible now?
Oh,
Am I audible?
yeah. Yeah, we can hear you.
What I was telling that Meredith has done a lot of adaptation. I feel based on her experience from different GDGs. One thing I feel that she has little delayed timing, which is much more convenient for me from joining India. It is 5:30 in the morning rather than 3 or 4:30 in the morning. Another thing I saw that what we just talked, Jessica, yeah, he has staggered it in such a way that it doesn't bombard from the beginning. That's a good thing. These
Yeah.
experiences I was sharing with even some GDGs in Europe, but I felt that they are very rigid. They don't accept some of the things which I suggested. It's just my experience. I'm saying.
Yeah. I'm having a really hard time hearing you, Pradeep. So if you have, it could just be me, I'm not sure. But Yeah, thank you, Meredith. So it might be better if you have those questions and comments, just put them in the chat, because I know you have like really valuable insight, because I see that you have taken a lot of these with different groups. I heard some stuff about timing, things like that. I think, I don't know that from my perspective, because I may do another one of these in the fall. And I think I'll probably do the infrastructure one, or I might do the infrastructure one. I'm going back and forth whether I do the infrastructure one or I actually do the ACE. I think it's like associate, more entry level exam for people, just to get a different group of people. We'll see. But I'll do that in the fall. And I think the timing probably be similar, just because I love that we have people from all over, but it is G2G Atlanta. So our events will kind of stick with like our East Coast time. Security network. You might have to clarify like what you mean by that. Party. Are you talking about in context of the exam content itself, or with the program? Yeah. So. Oh, okay. Yeah. I will GCP security or network engineer program. Okay, I'll consider it, or I'll find somebody who has more experience in those areas than myself. So yeah, I'm working on it. It's still kind of just me, and then Zach, my co-lead, kind of has his own program that he does things out of. So just two people, it's sort of hard. But I'm trying to get more collaborative resources in Atlanta, so I'm like not the only one doing this. Cool. So we'll discuss more kind of at the end. But so I just wanted to go through where we're at. I think, yay, we're at the end. So at this point, you should have gone through or started or attempted. It was 13 badges, so courses including lots of labs. Yes, these last two data flow courses were quite intense. I will get to that in a moment. So this is where we're at. I just want to say, before I even forget, thank you everybody who's been on this program, even if it's just been 1 week or all 6 weeks. I really appreciate it. Again, I selfishly did this because it was a program I wanted to go through, and this seemed like a relatively approachable way to do it and to have encouragement. But I didn't want to overthink it too much. At the end of the day, we're here to provide motivation, but we can't drag people across the finish line, right? So it's about kind of getting all the resources in one place so it's easier to access, so kind of where to go. Have people to kind of hash out ideas or questions, but at the end of the day, like, we all kind of go and are responsible sort of for our own individual journey. And I feel like we've accomplished that, but I've also learned like a couple little things that maybe I would tweak and do differently. So just a couple of announcements. In terms of our voucher program, I have 7 vouchers that are unspoken for so far. Just trying to be consistent with sort of what we presented at the beginning of this program. So on that note, at this point, if you want to be considered for one of those final vouchers, asking to kind of get through the badges by May 31st. At this point, first come, first serve. But I feel like based on who's still kind of left in the program, I have very high hopes that people will be able to get their vouchers. And also, to be clear, that's for people who made it to at least half of our existing events. So I feel like most people here couldn't get there. Now, yes, the last 2, the data flow sessions, courses, very intense, very time consuming. I myself have experienced that. So some of my suggestions: the labs themselves are really valuable, but yes, the coding content isn't particularly specifically tested for, right? So I think the most time consuming part is going through the labs. And I think they must have changed the program, because in the past with Dataflow, because you can do Dataflow in Python or in Java, it used to be that for each of those labs, you could pick the one, you can do either Python or Java. It seems like now with the latest iteration of Cloud Skills Boost, you have to do all of it. So yes, that was a lot. My suggestion, because even I don't know all this code off the top of my head. I don't code in Java particularly. So the Java stuff, like, really hard. I think being able to read through the code, read through the lab, there's a lot of contextual information in the labs that are really valuable, like why you're doing certain P transformations and all this embedded information that I think is valuable for having the contextual knowledge that is helpful for the exam. There are, if you haven't noticed, in the labs, solutions. You don't need to kill yourself trying to learn code or memorize all this JavaScript and all this Python. At the end of the day, I'd rather know that people are going through the material that is in the lab, which I feel like is valuable, and using the solutions diligently. Like, be efficient with your work, right? You can copy and paste the solutions into the code. It's okay. I would say your best use of time is to do that. Read through the code in with kind of the contextual information that is within the lab itself, so that you understand kind of in the chunks what is happening, right? And why we're doing this. That is the most valuable practice, I think, for the exam itself. Seeing kind of the process is really valuable. But for myself, who is a real life, if we were to go and do this, I would be on Stack Overflow. I would be on my Google documentation. I would not know how to code in either Java or Python this off the top of my head. I'd probably choose to do it in Python because that's my experience. But I feel like realistically, that is a very realistic way of doing things. So copying and pasting the solutions just to get through the labs is acceptable. And I will encourage that. So I will just put that out there. And yes, so just so you know, I myself have gone through this. Yes, it was a lot of work. It surprised me as well. I made it through, because I'm also part of a separate Google program where I will be able to get my own voucher, and I had to have it done by May 31st to be eligible, right? So I myself had to go through this. It is possible. So let's just get through that, and any further questions, comments, concerns, you can message me on the side. I also have a study guide, which is our one-pager. I have added some study notes that I've taken that is linked also within that study guide that has further notes about a lot of the things we've gone over. So you've got the one-pager, which I've shared in Slack. I've linked here. This whole presentation will be in Slack. It will be available. So the idea behind all these resources is trying to get the resources in one place that's easiest to find and study for the exam at the end. Because that's sort of the hardest, I think, problem is there's just lots of resources, and how can we have them all in one place that's like focused and easiest. Yeah, and then finally, if you register for the exam, once you take the exam or about to take the exam, your results, whatever, please share with us. We'd love to hear about that. No pressure, but yes, it would be very helpful to me. Whatever the end result is, hopefully it will be good. And yes, so please kind of keep sharing and following up with us. So those are the announcements. So today we're really, over the last several weeks, many weeks, we've gone through kind of more of the information in detail. Today we're kind of going to wrap it all up, package up kind of the big picture where we're at, what we've gone over, make some points, and then I have some Slido questions that we can practice and discuss. Yeah, so that's where we're at. Are there any, before we get into kind of just the kind of overview of like the exam content, are there any questions or comments? We can also save those for the end. It's up to you. Take a drink while I'm waiting. Cool. All right. Sounds good. Thanks, Meredith. Sweet. So, right, we're going to go through. So these are some of the high level things that we should be focusing on. I want to thank Pradeep for sharing a lot of great resources, places to have additional practice questions, practice exams, super, super helpful. So I encourage you to go in the Slack channel and look at those and use those. If you haven't already bought, a lot of people don't buy physical books anymore, but honestly, the study guide, the official study guide, which you can get on Amazon and is also linked in our event pages and documentation. I think it's also I have it linked in the one-pager study guide. It's also been really helpful, and there's a ton of practice questions in it, so I highly recommend it. Depending on where you live, you can probably Amazon it and get it pretty quickly. So we've gone over designing different data processing systems. So things to really remember is things like differences between batch and streaming data, the tooling that one can use for batch and streaming data, use of, at this point, you should have so much data flow knowledge because they've spent a lot on data flow and all of the abstractions. Understanding when you would use Cloud Dataproc if you're converting a distributed kind of processing from on-prem, like Spark processing, you can use Dataproc. Apache Beam is basically the runner that is on Dataflow that abstracts the processing. The idea of who can tell me the difference between an unbounded and a bounded P collection? Bueller. Maybe at the same time, somebody can tell me what a P collection is. So P collection is.
So what I'm remembering about P collections is that they are immutable. So they don't change. Rather when they get processed, you take one P collection in and you create a new P collection with the changes.
Yep, with the transformation from the P transform. Yeah. So the P collection is really just a collection of data, right? And it's stored. You can have all different types of structure of data in there. And yes, and it's a parallel collection so that it actually allows, so when the transformations are happening, data flow can actually decide how to parallelize the transformations on that segment of data, right? And bounded versus unbounded. Bounded is really just a batch of data. It has like a bounded beginning and end, start and end point. And an unbounded collection is streaming, right? So there's no clear, start and end point in terms of the data collection itself. And that's where we get into why we use windows and things like that. And what we do with late arriving data and watermarks in data flow. That all applies to the kind of the batch data, unbounded P collections kind of in data flow. So a couple other things, and I've included some of these in my notes just because they were kind of things where I was like, okay, what am I looking at, right? So the differences between and when you would use PubSub versus Kafka, right? Kafka is also a messaging service, but it's a managed messaging, is a self-managed messaging service. So there's some more customization you can do with it, but it's more complex in terms of it's not serverless. But one of the advantages of Kafka is if you need to, or if you wanting to save kind of your message streams, do more analytics on the actual messages, keep those for longer periods of time. you would maybe need to use Kafka, whereas PubSub, the default is keeping unrecognized messages for 7 days. You can store messages for a maximum of 30 days, right? So if you have any use case where you kind of need to keep record longer term, like caching of your records, of your messages, you would need something like Kafka, right? And then, of course, how would you operationalize some of this in like a pipeline? So scheduling the ingestion process, the processing, kicking off the data flow process, dumping it into a Google bucket or BigQuery warehouse. You can schedule that all through something like a DAG with Composer. So just some of those higher level concepts with processing. Continuing on that, kind of understanding, choices of infrastructure. Again, pointing out, like, if you have an on-prem Hadoop Spark process that you want to put on-prem, put on cloud, that would be Dataproc, right? You'd want to use Dataproc for that. And then the interesting thing with Dataproc is kind of the storage options that you have. One of the great things about putting things on cloud is that you have separation, or you can have separation of compute and storage. And so Dataproc is one of those products where you can really leverage that to improve kind of your efficiencies and not just how fast like you can process things, but also kind of the cost associated with having large-scale parallel processes. So with Dataproc, you most of the time you would have off-cluster storage. So you'd keep everything in a Google bucket, and then when you spin up your cluster to do the Dataproc like Spark process, you would have like a temporary VM that would kind of store in memory on the cluster just while it's running. And then once it's running, it's a preemptible VM. So it means it basically is destroyed once it's done, right? So that's a huge cost saving. So you don't have to have these on-prem clusters that you continuously maintain and pay for, even if you're not using them. There are situations where you would have the kind of the Hadoop storage that you would want to maintain, like in the cluster, and oftentimes that would be for like a temporary data set that you would have in an intermediary like process during the transformations. So if you need something like in memory, it would be much quicker. You'd have lower latency to kind of have that HDFS storage on the cluster while you're running it, but your like raw data and your end data would basically be in like Google storage, right? So you'd still have that separate, and you just kind of have the intermediary layer, which that could be a use case where you would want to have kind of HDFS storage. And let's see, other things that were interesting about this is just understanding that PubSub doesn't guarantee that the messages will arrive in order. That's kind of why we use Dataflow. You can use transformations to ensure that you order the data correctly, use Windows to make sure you're collecting all of the data, not having and accounting for latencies and delivery, things like that. So, and also PubSub doesn't guarantee that a message will be delivered once. You can have a message delivered. You could have duplicate messages. So again, that's sort of why we do the processing in Dataflow to kind of ensure we're counting things correctly, they're ordered correctly, you're gathering kind of your windows correctly. That's sort of the whole meat and potatoes of what's going on in Dataflow. So again, a lot of this has to do with migration. So one of the things, like when I was taking a practice exam, and this is just me, like I realized, I was not remembering so well, like migration of data, like what tools to use for migration. There's several different ways to migrate data from on-prem to cloud, or between different regions within cloud or different parts of the cloud. And I mixed up kind of, I was like, oh, I don't really know which one's which, right? Or why to use them. So this is why taking the practice exam is really useful, because it was something very easy for me to go and look up and make sure I would remember it. But I didn't know kind of, oh, I was lacking that bit of knowledge until I kind of noticed there were a couple questions that I was unsure about that were sort of related to the same topic. So in this case, you know, there's cloud transfer. The two that are really kind of important to remember are the data transfer service and the transfer appliance. So the transfer service, I've already like now made my brain go backwards just from like talking to you guys. So you have the transfer service is for when you need to automate between like another cloud service and Google Cloud Storage or on-premise data. You can transfer large amounts of data by using the storage transfer service. The transfer appliance basically is, let's say you need to transfer data. Either it could be very highly secure data that you can't transfer kind of over the internet, or it's going from a place where you don't have internet connection or you have low capacity, or it's just so much data that it would be even too unwieldy to transfer. So transfer appliance is actually like high capacity storage that you ship your data to a Google facility and they upload it to the cloud. So that's kind of, so remembering kind of storage transfer service. Most situations where you have like more than 1 terabyte of data and you're transferring between another provider or on-prem to the cloud, Google Cloud, storage transfer service is probably going to be what you use. Transfer appliance is like much more specialized and would be for like huge data, highly secure data, don't have bandwidth to do the transfer. Those are some of the things you should look for kind of, and that I saw in some of the questions that sort of indicated, oh, this is when I use the transfer appliance. And if you have little data, like basically less than 1 terabyte, and you don't have kind of network issues, you can actually just use like the gsutil command, the Google Cloud CLI, and copy data that way as well. So you have several options, and those are good things to know. And I didn't accurately know that when I took one of the most recent practice exams. So the other things like that you'll see is kind of different data processing. So understanding when you would use Cloud Bigtable, Cloud Spanner, Cloud SQL, BigQuery, those sorts of things. And I've included this in some of the additional notes that I wrote up and linked in the study guide, kind of the very easy like tables and some kind of short like snippets of the differences and pros and cons and where you would use one or the other. Cloud Bigtable is an analytics warehouse. You can do processing, storage. I think I have at least one practice question coming up that is kind of on some BigQuery situations. And you can use standard SQL, and then there's also some other like DML that you can use in BigQuery as well. Cloud SQL is just like a more lightweight SQL warehouse. It basically is like a one-to-one to MySQL. It's not offered in every region. It's more for simpler use cases, standard SQL database. Cloud Spanner is highly available, highly scalable. And it's more like row-based operation. So if you have streaming data, clickstream data from an application, a Cloud Spanner database would be like a really good use case, especially if you're feeding like clicks application data back to an application, you might use Cloud Spanner for that situation. So it's kind of a row-based operations. It's much more expensive than BigQuery, and Bigtable as well is much more expensive than BigQuery. But again, you're looking at like row-based operations. And so, yeah, I have kind of more study guide kind of tools to kind of remember the differences between all this. The other questions that I've seen have to do with storage, kind of knowing the difference between standard storage, nearline, cold line, and archival, and sort of like they have to do with kind of the regional availability of the data, how often you're going to be using the data. So, if you're using the data every few months, it might be nearline. It keeps in one region. Cold line is just like if you're not using it more than like once a year. Archival is literally just archive data. You're not going to be using it, but you need to maintain it for whatever reason. And of course, they come at different price points, right? So the less kind of you're having to pull data and analyze data or for whatever reason, cold line is 90 days. Thank you, Pradeep. It's cheaper. Cool. So then other things like just recognizing that BigQuery can be used for a lot of AI and ML ops testing. You can do a lot of baseline ML models right within BigQuery. And then like you can extend on that and build out into Vertex AI notebooks and do kind of almost like a Jupyter notebook platform where you can do test code and test models. Basically a great place to build like baseline models, kind of see where you're at with your data, and then you can extend on that in like MLflow, Kubeflow, and build kind of more robust like productionalized models. But like there's a lot that one can do. I know people have asked like, hey, like what if I'm just building a report for somebody and I want kind of general models? Like there's probably a lot of reporting and baseline like ML models that you can use kind of in a C-suite level sort of report or feedback that you could run right within BigQuery. It's really once you kind of are getting into the process of, hey, we think we have a model that indicates some utility. We want to, improve on that model, productionalize it, constantly retrain it. That's when you need to start about thinking about some of the other AI applications within GCP that offer more like customized models, auto ML, retraining, things like that. So that's where you would kind of look into some of the AI APIs, the AutoML, Vertex AI kind of pipelines, right? But BigQuery ML is a great place to get a lot of testing done, I think. We have, I think the last couple of weeks, talked a lot about some of the data processing. Again, I would say this study guide book has several chapters on the different tooling for that. And it's really easy, really well explained in there as well. So if you're somebody who kind of works while studying that way, I highly recommend that. And I've also like linked kind of all of the slides that were associated with the Google Cloud Skills Boost courses. So if you're somebody who's like, I can't listen anymore to Google Cloud Skills Boost. I've listened, I've checked it off, but I want to go through the slides. It's all linked in the study guide. So it's all in one place. You don't have to like click through Cloud Skills Boost anymore to get that. Again, kind of going back here, Dataproc, similar utility and idea of data flow, but it's specifically for parallel processing pipelines, Spark, Hadoop type pipelines. And it has like capabilities, and honestly, Dataflow has these capabilities too, that it kind of auto scales, does some of its own like uh, um, automation of, okay, what actually is, how it's prioritizing kind of the workflow and the transformations, and the parallelization of the transformations. A lot of that is why you end up using these products, because they are these serverless products that are able to sort of handle the scaling of the processes. And so when you're thinking about these tools and the exam, really thinking about the idea of these are serverless products versus managed products, and the benefit in these cases, in like 90% of use cases of a serverless product, is sort of all the things that are abstracted away that you, as the user, as the engineer, as the data scientist, as the analyst, as the business intelligence officer, whatever, don't have to kind of think through all of those little details, like, and how to optimize those. Even the default scenarios for a lot of these tools tends to optimize decently well, right? And it comes down to, if something, you end up using the cloud logging and cloud monitoring to get feedback if something is getting, a process is slowing down, particularly something that relies on streaming. That's when you would use those tools, like the monitoring tools, to kind of figure out where are your bottlenecks, and then you can go in and kind of improve some of the customizations behind the scenes to ensure that those bottlenecks aren't happening. But a lot of it kind of is lifted up front, which is nice. And again, this isn't, we're in a Google program. I use, but it's one provider, and all of the providers really do kind of these very similar things. So really, when you're kind of thinking about it, just think about just serverless in general, like what you're gaining from using any of the products within those cloud ecosystems. Let's see. Getting back into operationalizing, got it, machine learning models. Again, BigQuery ML can actually get you, yeah, thanks, BigQuery and ML can get you pretty far in terms of testing, just, where you're at, what your data is doing, getting kind of baseline ideas in terms of models. And then you can extend on that using the slew of tools that kind of go from, prepackaged models, pre-trained models, all the way up to customized models using Kubeflow. So you had kind of all of those options. In the labs, we worked a bit with some of the ML APIs, some of the pre-trained stuff in image classification, sentiment analysis, and yeah. So, and again, kind of understanding when to use one or the other. So in the exam, if, again, we've talked about process of elimination with some of these questions. It's not always super clear. They can be kind of convoluted, but looking for keywords, like if they start talking about your data's in BigQuery and it's, average size data, and you're looking to build baseline model or test your assumptions, probably BigQuery ML, like we'll cover it. If there's something in the question that indicates the user who's building this is an advanced user, knows programming languages, like knows how to write custom models, then you're maybe, that person could be using like AutoML, right? Or Kubeflow pipeline, because they would have the skills to do that. So kind of parsing through the questions to notice like who the users are, who the end users are, what the use case is, and really like lining up the boxes to figure out what are the appropriate tools. Because as we've seen, the Google Cloud has multiple tools that could be used for like any given problem, right? And sometimes it's not even super clear what is the best tool given the problem. You kind of just have to like weigh many different options and scenarios. And as convoluted as the exam is sometimes in terms of, really it's sometimes hard to figure out like it seems like there could be more than one correct-ish answer. I think actually, I've come across that even in real life, right? Like my use case, like in my org, we use Composer Airflow a lot for scheduling our processes, but like we have some Airflow Composer DAGs that the process is doing is pretty simple, and it almost seems like overkill to be using Composer, where you can just do Cloud Scheduler, right, or something in the background, and it wouldn't be so much a big deal. But we have like a history of using Cloud Composer, and it gives us certain amount of logging and an output that for us is tied into like our alerting system. So that's why pretty much for everything, we just write it in a DAG, even if it seems like we have to use more code sometimes in the DAG than the process itself. So like, even though if I had a question related to like, oh, it's a simple process, blah, 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 and maybe Cloud Scheduler or something would be more appropriate, just know that in real life, like sometimes the answer to what you use is because it's already being used. It happens. So it's like, that's just the historical context of what's being used. We do have like more technical reasons for it, but sometimes it seems like that's comes down to it. Understanding deployments of the machine learning models, the different types of models. There were some like basic, like a couple, I think in the few practice exams I've taken, of all of the questions, there's 50 questions, excuse me. Maybe 2 or 3 on each exam have something to do with machine learning. Again, there would be a lot more for the exam that Meredith is going to be teaching for in the machine learning program, but they still have, an expectation of some understanding of different models, understanding if we give you a scenario, understand what would be an appropriate model or use case, right? Differences between like supervised and unsupervised models, the different types of models that fall under those. Thank you for sharing that link, Party Ape. You can refer awesome GCP YouTube channel plays how to eliminate wrong options. Oh, that's really cool. I'm going to include that link in our, I'm going to capture that before we leave, in our study guide later. So I'm just going to throw this up here. Okay. Before I forget. Cool. Going through, sorry, I need a drink. Cool. One of add a whole section to my little kind of paragraph and bullet points to my study notes, which I will share about GPUs, CPUs, and TPUs. I think, again, not too many questions, but I did have on the most recent one, I think I've had like one question each in the last like 2 exams I've taken, 2 practice exams that had to do with GPU, TPU, CPU, like what to use, when, where, what. And totally got wrong. So I've added like a whole little study section on kind of the differences there and where you would use one or the other. So that's like one area that I think is just helpful. Again, some of these, like, it's not super hard to know, but again, it's 50 questions. You have to get 35 correct, I think, to pass. And so, one of these questions that I got wrong, I was like, oh, if I knew kind of that TPUs like can't be used with operations, it would have been a very easy question. Like I would have immediately been able to like get the answer, right? But I didn't know that or remember that. So it was like, that's one question that I could have had, like that would have been very easy. So again, just kind of capturing some of that. And I have in the notes, which I will share. Cool. Yeah, and then again, like I said, classification, knowing the difference between classification, regression, just some of the key words. The questions that are machine learning on the exam are pretty high level, but again, there's a couple. You will have a couple. So having kind of the high level understanding, making sure you just kind of generally know, supervised learning, unsupervised, regression, classification, different evaluation metrics at a high level, you should be good. And then kind of data security, IAM, identity and access management. There were like one or two questions on like authorized views. Authorized views is a way, like there was one question. Actually, this might be one of the practice questions I give, so I won't give it for now. But yeah, so like understanding authorized views, different kinds of security and roles that you can give. I haven't noticed too many on this. Again, like one or two, but it is kind of good to have an understanding of like Google managed keys, customer supplied keys, some high level roles. From a practical like job standpoint, I am surprised. Well, maybe I shouldn't be surprised that for me, like learning the IAM roles and kind of how we assign them and kind of different security protocols and assigning roles to like projects versus data sets. I would say none of the exams get into the weeds with that, but for me, like on a day-to-day, it's actually pretty important. And for us, we assign those roles, we build those roles out. It's part of our infrastructure, and we build them out in Terraform, which is building infrastructure as a service. So you're basically building, requisitioning our infrastructure within code. And so that's how we assign, like we build out all these roles, and we give different tools, like the ability, like certain people and certain tools can access certain data sets in BigQuery and not others, right? So it's how we kind of control that not everybody can suddenly like spin up a Composer DAG and like completely write over our production tables, right? So we control a lot of that with our access patterns. And one way to also control kind of the consistency of the access patterns and also have history and lineage over that is actually writing it in code. So writing it as infrastructure as a service through Terraform. This is extra information. Again, I don't think I've seen any questions on it, but I would say just again, practical day to day. It's really, especially if you're in a larger organization that is having to kind of manage a lot of users. Access management is really, really important, and understanding kind of having source control or some kind of control pattern, data governance over this is very, very, very important. So I will encourage, study this again, just enough to get through the few questions on the exam, but I would take time because I think it's valuable, whether it's data engineering, ML engineering, analysts. Basically, if you're going to be touching GCP in your life or in your work or whatever, understanding kind of these access patterns is really valuable to, for lack of better words, to not have an oh shit moment. It happens. So, and truthfully, if you're in a smaller organization that doesn't have these things very like robustly built yet, it's easier to have an oh shit moment because oftentimes there's people who have way more access as individual users than is healthy. Just that's kind of what happens. And usually once an organization starts getting bigger and they start hiring people into like security roles and data governance, that's when everybody's like, oh, wait, why do all these people have access to all these things? And then they start putting in these processes. So just be really, really mindful of whatever you're doing, like what you as an individual have access to, and maybe working to, improve that so that you aren't a victim of accidental something. Cool. That is my PSA for the day. Yes. And then pipeline monitoring, test suites. Here, the last point, kind of understanding serverless versus fully managed services, the pros and cons advantages to those. The nice thing, particularly about some of these serverless products within GCP, is a lot of them are automatically connected and automated with the cloud monitoring, Stackdriver, logging. So there's very little lift. You can improve kind of how those products all work and the reporting that you get from them, but usually at a minimum, there's like a default settings that you're getting some of that information. So basically, just by having anything running in GCP, if you know where to look, like you'll get some of that monitoring and logging automatically, which is nice. You can just improve on it if you kind of know a little bit more about how the products work. Portability, tags on your resources. Yeah, so data catalog. I haven't seen any questions yet. There's a newer product in Google called Dataplex, which is their data catalog system. It's actually really, really cool. It automatically connects to like BigQuery, a couple other services, and it shows you can see like the lineage of all your data, the transforms, like it kind of has it all in one place. It's an in-place data catalog. And it's like very, very cool. So, but it's very, very new. It might even be pre-general availability at this point. We're using it, but we're only just starting to like scratch the surface. So that's also a really cool thing. Again, I haven't seen really any questions on that just yet, but they update the tests pretty, I don't know how, like at least like once or twice a year, it seems. So just be prepared like for anything. And then yes, some of these products in Google are open source, originally open source. So Airflow Dataplex is like a data architecture service, system architecture. Yeah, I mean it's all the things. It's like you click around and you can. I think it's pretty cool. Again, it takes a little bit of management to get like the most out of it. But even just open box, we're already getting way more insights, data lineage, and utility around like our data, the schemas, kind of having it all in one place than we had before. So for us, it's been really valuable. And then, yeah, so the open source. So Dataflow is Apache Beam that Google has built into GCP. Composer is basically Apache Airflow that Google has built into GCP. Just the pros of that is that there's documentation all over the place for these open source products. There's also sometimes the external documentation gets you further. Although I will say, like for Composer, there are particular like gotchas for like the Composer itself. So Airflow within GCP that doesn't always one-to-one translate to the pure open source Airflow. But most of your external like open source resources will get you there. Google has also built kind of their own operators and functions and stuff that are particular to the Composer build. So that's just sort of some of the additional things to kind of keep note. The other thing to keep note about some of these products, Dataflow, Composer, Dataplex, which is kind of the point and click, or not Dataplex, Dataprep, excuse me. It's all these names kind of go into each other after a while. Is that's also like a third-party tool that is connected to GCP, and you could run into situations at work, like if you're in a very highly secure environment, that using some of these tools, even if you have like a private GCP instance in your organization, some of those like connected third-party tools may not be allowed just because of the data is kind of getting external a bit. And so you have to kind of understand like, okay, those external tools, so Dataprep might you might not be able to use it for your particular use case due to like different security things. So just some of the things to keep in mind. And something like that may actually come up in a question, like, because I noticed there's a couple, not lots, but there's a couple of questions that are like all these long like case studies. Like it gives you this whole situation, and at the end it'll ask like, what do you do for this, like this step, kind of to build out this product within this particular business use case. And so there might be questions that it gives you a use case that's like a particular, like highly sensitive, highly secure use case. And in that situation, maybe some of the products aren't appropriate just because of things like that. Right. There's no actual SQL questions, but again, just from a practical standpoint, in terms of doing this in real life, writing SQL kind of goes hand in hand with a lot of this, particularly with BigQuery. I use BigQuery and write SQL pretty much every day. All right, Python every day at minimum in like my Composer DAGs. And then, back to some of the PubSub patterns, windows, the different late patterns you can have, and knowing that the late messages, the customized like late messages, like that only works in Java. So that's a big one. And just again, there are like use case questions and case studies. So understanding conceptually like how to apply these things and not just memorizing this product is used for this and this product is used for that, is really what's necessary to be able to kind of get a lot of the questions correct. Cool. Okay. Whew, that was a lot. Longer than I expected, but yeah. Again, some of the stuff I busted through, I have added out to like an additional study notes page that I'm linking in the one pager. I will reshare all of this with the updates in our Slack channel tonight, as well as this slide deck. So everybody should have all of this. And I usually post the recording tomorrow. So awesome. Yeah, really great tips. I'm hoping to take the exam in June. So that's the other thing I would say. Get through the labs, or whatever you think is necessary. And that's also one of the reasons why I really encourage that and have like the deadline by May 31st, just because I think like we're all very busy. We're all have so much kind of going in and out of our brains. It's hard to retain like the details, right? Especially if you're not doing it, or doing it regularly. Like this is a great starting point, but from an exam standpoint, I feel like you really, really want to kind of get this under your belt as soon as possible. I'm getting the Slack channel, and then we'll go into the practice questions. Oh, I didn't mean to do that. Let's get everything back. No, don't look at my code. I should have thought about that. That was not proprietary, but it could be. Where did my thing go? Lordy. Nope. Give me a second. Give me slides. There we go. Okay. I am actually working on a really fun project at work. But I had to edit the recording. There is nothing super proprietary in that. It's part of our hackathon. So let me get the Slack channel before I forget. It's just easier to share it. And then I want to go through these questions pretty quickly. Copy invite. Here we go, Xavier. I'm posting it here. And then we're actually in the, can I share the actual channel? It's this channel, like with, oh, why did that not work? It's the Rode, oh, geez, Louise. Did this work? There we go. It's that channel within the workspace. Cool. All right. I want to get through this. Cool. because I do have a bunch of questions. So we're all going to get on Slido, slido.com. And I'll give you all a little bit of time to get on. I will say, like, let's try to answer pretty quickly. I'll give you more time now to get on Slido, but the next questions, like, we're gonna, I think in the past, like, I've let like quite a few minutes go for each question. Let's be a little more diligent about our time. I think I've been talking a lot today. My throat is like, So yeah, I talked about a little this earlier. While you guys answer, I'm looking at that. I'm gonna adjust some of my notes. Pradeep shared that great YouTube channel. Awesome GCP YouTube channel. I'm gonna put that here while y'all are answering that. 6 hours, you guys probably. Okay. All right. Awesome. That's 8. That's half of the people. Oh, people came in while I wasn't even paying attention. All right. 14. Okay, I'm going to go. Wow. You guys are so smart. I love it. Yay. Look at you. Yes. Use the transfer appliance to copy the data to cloud storage. A+. Yeah. So this is one, like, I got this question wrong. Sad. But I just had to remember transfer appliance versus, cloud storage and things like that. And it becomes an easy question. So every question counts. Awesome. Next question. What are 2 of the benefits of using denormalized data structures in BigQuery? Oh. 3. Seven, 8. Of course, this question assumes that you know what it means to denormalize data, which if you don't, after today, you should. Okay, 9. That's about how many answered last time. So we'll go. Increase query speed and make queries simpler. That is accurate. So can anyone tell me what denormalized data means?
I think of it in terms of what it's not. So when I think about normalized data, I think about having all these different tables that you have to join together. And each table has its own set of facts or dimensions. And so denormalized is when you smush it all in, all the information into one table.
Yes, exactly. That is a perfect way of looking at it. So knowing that kind of helps answer the question, because in actuality, you're not reducing the amount of data you're processing. You're actually increasing the amount of data because you're technically increasing the amount of rows, right? But you're reducing the amount of joins that you have to do in the processing, which that's what takes a lot of time. So it's that trade-off. So you have to process more data, but it tends to, the syntax of the query itself will be much simpler, as well as the speed of the query, because you're not using any joins. But like this, not correct, because it doesn't reduce the amount of data processed. It actually increases the amount of data processed. It actually increases the storage for that data. So again, kind of thinking about that concept, that's what's really, that's kind of, joins are, from a processing standpoint, are bad, right? So that's why, yes, you'll see a lot of denormalized data structure or normalized data structure, but if you are having to do a lot of process that requires joins often, that would often be a case where you would want to have a denormalized table, if you're going to be doing that process, that analytics process a lot. Yes, Elena, what is your question?
Hello, can you hear me?
Yeah.
Oh my God, hi. So yeah, what if a table is nested or structured? Is it considered denormalized or not? Because in that case, it would reduce the amount of storage required, because the amount of columns would decrease drastically if it's like a nested structure, right?
But if you have nested columns,
it's technically denormalized because you have every column as a separate table, if you could think about it that way. So it is denormalized, but it would reduce the amount of data processed. Maybe I'm just overthinking stuff all the time.
Yeah, I guess it, I don't know if it's that would have, yeah, because I don't think it's technically normalized data, because like, yes, I get what you're saying, like those nested columns are technically like a table within the column.
That's denormalizing,
but not in the traditional sense. What's that?
It's denormalizing the table. If you combine several tables into one, it's still denormalization. You just don't put them as separate rows, but like structure them together in a nested way. Okay, so the question was about the something very general, and I'm overcomplicating.
Yeah, but I still think that's not like, it. Yeah, I mean, it may be that's denormalized, like, but you're still. I don't know that that's still considered like completely denormalized, though, is what I'm. Because like completely denormalized would be then unnesting all of those nested columns into individual columns. That would be denormalized. Because like there are a lot of like there's like several different SQL like processing steps where you have to unnest the nested columns to even be able to do the step.
Well, if it's structured, then you don't need to unnest. It's just the BigQuery is complicating this stuff. Sometimes it's called the same thing, structured and nested, but it's different. And if you have something like, for example, you join a customer table to or whatever table, and you have customer first name, customer last name, but just one row of that data, then you, instead of two columns, you have one column, which is a customer, but it's structured into the name and the last name.
Right.
So it is, you don't need to perform the join any longer. It's all in one table. So it is denormalization. And you don't need to unnest that because it's just one row within that structure. Okay, you know what?
Yeah,
Just forget
I guess
my question.
I get what you're saying. I don't know that when I think of a completely denormalized situation, that is not what I think of.
Okay.
So I think it's a special case, but yes, you can still run on that, but it is.
Okay.
As far as I know, question is concerned.
Okay, cool. Thank you for taking the
So
time.
I get what you're saying, but I could be wrong, but again, you're still having to, I don't know.
Could I say something? So for
Yes,
me,
please.
for normalized data is where you keep data in one space, in one spot for the entire database, so that all the tables, if they want to get access to that data, they go to that one table. When you denormalize data, you're duplicating that data in other places, so you don't have to go to that specific table. So in that case, these nested would be denormalized, but that's not the only place you would denormalize to increase speed, right? I think denormalized is more like you duplicate the data in many places to increase the speed. So for example, Cassandra, NoSQL databases, they denormalize data. They have the data in multiple places, and then that's how they increase speed. But they're processing much more data because in order to get to all of the data, they have to go to all of the spaces that the data is. So if the data is duplicated, you have to process the data at each of the spots that it's duplicated in order to, so you have to update the data, right? Mm-hmm. So that's why, that way, I think anytime you have denormalized data, you're increasing the data process, because in order to change that data, you have to access it in multiple places. You know, that's my view on it.
So I think it's actually backwards, because, or maybe I'm just not understanding, because normalized data is data that's in multiple tables. Denormalized data is the combined.
The actual data is in one spot. When you normalize the data, you're putting, like, say you have an address, you have the address in one table, right? You don't have, you have a table for zip code. The actual zip code is only in one table, right? It's not like you have zip codes in multiple tables. So when you normalize data, you're putting,
so normalization is you have multiple tables, so there's no redundancy.
Right.
Redundancy.
But denormalized, there's redundancy because you're putting the data in multiple places. Maybe I'm confused.
You're putting it, to me, denormalized is you're putting it in multiple places. Denormalized is combining the data. You'll have multiple rows, like repeated rows of the same data.
Yeah, that's what I mean by that. Yeah.
But it's in one place.
Yeah.
You're combining it.
Multiple rows with the same
so
data.
You could, it's like, becomes a one-to-many relationship.
Right.
What's that?
Multiple rows with the same data,
Exactly.
Yeah.
Exactly. So say, like, you have, in a sales situation, you'll have, like, in your normalized data, you'll have one table that's your list of customers,
right?
One row per customer.
Right.
You'd have a table that's all the sale invoices, let's say, or item IDs, right? One row per item ID. Then you might have a table that's all of the purchases, right? Individual purchases. Right. Now, one person may have like 5 purchases or 5 things on one order. So if you were to denormalize that into one table, Jessica Rudd, right? And I bought 5 different SKU numbers, right? 5 different products. Now, if I denormalize that, my name will be in 5 different rows.
Right.
It'll be Jessica with apples, oranges, bananas, strawberries, lettuce, right?
So that's more processing.
That's denormalized.
Right. So you have to go through each row to process more.
it's more data. Yeah. Yeah. So, but what the question is saying, like one of the benefits of doing that, say like you are asking questions that are constantly requiring you to have all of my orders in one place, right? Because say like the question you're asking constantly requires you to make that table join, right? It makes sense to denormalize the data into one table so that you eliminate having to do that join every time you run that analysis.
Right.
That will greatly reduce your processing costs. So that table itself, you have to process more rows of data, but your actual overall processing costs and like in terms of the time will decrease.
Okay.
Yeah. So I think that's kind of what the question is getting at, is that the query itself will go faster, and then like writing that query is simpler because you're not having to write the joins.
Yeah.
Right. So,
Yeah,
but
so
Elena, I'm sorry I couldn't be more clear in my response to you because I get kind of where you're getting at. But yeah.
yeah, so querying is much faster, but writing or updating would be much slower for the normalized data, right?
Writing or updating,
Right.
because you have to go row by row. It's like,
Yes. Mm-hmm.
yeah.
Not only row by row, but as Rick mentioned, the data is duplicated. You have to do all those
Yes.
updates into different places.
Right. Yeah. So if you're doing something where you have to update my name, right? Yes. Rather than having to do it in one place, now you're having to do it in multiple places.
In 5 places. Yeah. Mm-hmm.
So some of this, like, it depends on like what you're doing, right? Like your use case for the data itself. So, I don't know. I think there maybe could be further offline discussion about this. But yeah, that's all I got on this for now. To be fair, I put the question here because I got it wrong. Cool. Oh, I think I just gave that question away. What happened here? Ah, okay. Yeah, so here's a machine learning question. Look at the last questions. Okay, we almost done? Okay, I'm going to move on. I will say we're getting close to time. I have 4 more questions after this. I can go faster. I can stay on. Again, we're recording this, so if you need to go, feel free to go. Totally okay. Cool. So we will move on. Cool. So use deep learning by creating a neural network with multiple hidden layers, automatically detect features. That one is correct. Clustering does not detect faces. not used for that use case. Feature engineering, feature to add features for eyes, nose, mouth. Again, you would need to learn like what those features as pixels actually are. And nobody got the last one. That's good. So yeah, so the correct answer is they use the deep learning question. And yeah, so deep learning is really cool if you're not familiar with it. Basically, each layer subsequently kind of effectively learns a different feature itself. And then it kind of adds on to the previous layer through kind of the loss function. And then the output at the end, the last layer is basically like the output of, you know, whether it's a face or not a face situation. It just depends on what kind of model you use in your output function. So what's interesting, you know, when I was going through school is like, these models they seem all complex, but effectively what's going on in between, you can really break it down to like linear and logistic regression at like the smallest level. It's just like way more complex feature space and then layered on top of each other. So I would get in fights with computer science students. Cool. Which of the following statements about wide and deep learning model are true? Again, there was like, I think this test I took had maybe just these two questions on machine learning or models in general. So there's not a lot out of the 50 questions, but again, it's one of those things where if you learn it, you know, it could be relatively short, easy questions, or not easy, but questions that are like you get, right? That go towards hopefully the 35 you need to get correct. And I will say, if you want to learn more about this or aren't so sure about this topic, I have a link. I also added a link to kind of the Google documentation of like their research into wide and deep learning models. Pretty sure I did, at least now that I think about it. Double checking. Oh, data beam. Service. Where did I put it? 9. Okay, well we got the 9. So closing out. Good use for wide and deep model recommender system. Great job. The wide model is used for memorization. Deep model is used for generalization. So I see like a bunch of people got the opposite. Again, this is just learning the material. You know, embarrassingly, I also got them backwards when I did this. So, but there is like a good blog post. I'm going to make sure I put that. I throw that in the documentation. Oh, I have it there. Good. So it's in the one pager that I'll share. Cool. This is the question I had started to discuss. And then I was like, oh, wait. This is a question. So they give a user read permissions for only the first 3 columns of a table. Elena, the last question, there's 2 correct answers. You have to select 2 answers. Yeah. So it was the recommender system, and then I've already got my brain backwards. I think the wide model is used for memorization, deep model is used for generalization. So basically these first 2. Sorry about that. No, don't say sorry. I didn't make that clear when I read the question. Sorry about that. Cool. Back to this one. Authorized views. Yeah, y'all should get this. I basically gave you the answer. Hint. It happens. On that note, yeah, authorized views. I'm going to make sure I have this reference as well because I thought it was interesting. I was less familiar with authorized views myself. But yeah, you can actually, it's particularly useful if you have like one table within a data set that you want to share with people, but don't want to share like the whole data set or project level permissions. And then also can go even more granular than that and share like specific columns within a table. Again, useful if you have like protected information and you only want to share some of the columns, things like that. So it was also an area I was less familiar with. I'm gonna click this link while I'm here, and we will. There we go. Cool. Alrighty. What are all the BigQuery operations that you are charged for? There's this one and one more question, FYI. Cool. Let's see what we got. Storage, queries, and streaming inserts. Very good. Yeah. So importing and exporting data, no. Streaming inserts, yes. So yes, you're charged for the storage, the queries. Most of your cost in BigQuery will come from your queries, which is why writing your queries and really being cognizant, like BigQuery does you a great favor. It tells you like how much data you're going to process in your query before you process it. So make use of that because really making your queries as efficient as possible, processing the least amount of data that is necessary to answer your question. That's, yep, dry run. Thank you. That's like really, really valuable. And actually, like once if you have data like stored in BigQuery, like, you know, we use ours as our data warehouse, right? So there might be data that's sitting there. If it's not updated or processed or queried within a certain amount of time, I don't know off the top of my head how long it is, but it might be a couple months. The actual charge on that data like goes to a fraction of what it was. It kind of is automatic. As soon as you run a process on it, that kind of turns back on again. But if it's sitting for a while and it hasn't been updated, hasn't been queried or anything like that, Google kind of automatically adjusts like how much you're being charged to even store it. So cool. This is it. Last question. So use Cloud Data Prep to create a recipe on a sample of data in BigQuery table. You want to reuse this recipe on a daily upload of data, the same schema, after load job with variable execution time completes. What should you do? Cool. Yeah. So I thought I liked learning that you can actually use Cloud Data Prep to make templates in Cloud Data Flow for those of us who maybe don't like writing the code as much. And then, yes, you can schedule this using Cloud Composer. Cloud Scheduler, in my experience, is not as robust in terms of scheduling like multiple connected processes. So Cloud Composer is the more appropriate tool to do a scheduled pipeline in this way. So, and now you know. And like, this is one of those weird questions because, okay, the last one is wrong. Nobody got that. That's great. But I also feel like, I think like you could do some of these others. They're just less correct is more the gist of it. So, which fortunately, unfortunately is kind of the gist of the exam. Like sometimes things are more correct or less correct than others. Yeah. Oh, yes, because you can dynamically. So Rich saying the variable execution time might be a hint at Cloud Composer. Yes, because of like you can then use that as like the dynamically executed variables. Yeah. Within the template, which actually you can't do if you did this just in Dataflow. So, note to self. Okay, those are the practice questions I have for today. Everything else we've kind of talked about a bit. This is what the exam is like. It's 2 hours. There's 50 more multiple choice questions. You have to get a 70 to pass. So, do the math. You can register at this web assessor link. Again, I have a couple more vouchers left. Do what you will. And hopefully by May 31st, and we will talk. Again, as you've seen, a lot of this is just really practicing the practice questions. I've noticed the more practice questions I see, I get a little bit more of a feel for the expectations. But then again, like, you know, Rich pointed out in this last question, like there was kind of a key there that is a little hidden. But reading is like super, super valuable in this sense. And it does help kind of do the process of elimination in most cases, technically in all cases. But again, like being able to pick up on that really just comes from like having as much knowledge as possible. Deadline for taking the exam before the voucher expires. I don't know off the top of my head. I feel like the vouchers that I've had for previous exams were good for like a year, but I'll double check because I'm pretty sure it might be good for a year, but I will double check that it's not like something like 6 months. Although I will really, really encourage, like, I know for me, like, oh, is it 4 months, Elena? Okay. Yeah. And truthfully, I wouldn't want to wait longer than that. I would not remember half of this. have the like these details, right? Because some of these things, it's been really valuable for me to know, but I'm not using them on a day-to-day basis. So unless suddenly I start having to use data flow like tomorrow, I don't know that in 4 months from now, I'm going to remember every detail about all that data flow stuff, right? So that would be, I'm reminding myself of this too. I've basically told myself I'm taking this exam before sometime in June, only because I'm traveling in the next 2 weeks. So before I know it, it will be June. Yeah, so that's my recommendation. We live in a world now where you can opt to take them in person or at home. I know some people may only have the option for whatever reason to take them at home. I recommend, if you do live near a test center and you're able to get there and you feel safe traveling to outside place, I find the testing experience better and less invasive. They have such strict rules about ensuring people aren't cheating. Obviously that's good, but by taking the test in your home environment, like I basically had to rip apart my whole home office to like comply with the home test experience. So it was a bit much. So I think this one I'm going to a location just to not have to deal with that. But I realize not everybody has that option. So I just want to like put that out there in case you're questioning, like, seems convenient to take it at home, but it's in its own way a pain in the ass. Paul says, never take it at home. Yeah. I like the first time I did it, and I took one over COVID. So you had to take it at home. I just about cried because it was like so invasive. I've heard of taking the test in a bath. Oh yeah, because basically like you have to be like just on your laptop, no extra screens, no mirrors. Like say like you're in a room and there's a mirror behind you, can't do it. You can't be in front of a mirror. Yeah, it's like absolutely nuts. They make you video, they watch you. You can't have a watch on. I had like a medical like wristband thing on, and I guess it looked like a watch. And halfway through the exam, my phone started blowing up with the guy who was like monitoring me, like telling me, you must take your watch off immediately. Like all of a sudden I'm like, I'm not wearing a watch. It was so stressful. So like, yeah, do not recommend. Yeah. So FYI. Cool. Yeah. So there is a link to some sample questions. That's like a Google form that's on like it's linked here. It's linked on Cloud Skills Boost. But that's just like one list. Honestly, we have shared a lot of resources in Slack. I've tried to, as well as here, I've tried to accumulate all of those and include them in the one pager and the study notes. Again, I will share after this. The book, really great, even more questions. I'm just noticing this over time. The more questions I take, the more questions I see. It's just as helpful as it can get. Yeah. Are there any questions, comments? We're way past time. Apologies. But this was kind of our last official visit, so I guess it's okay. If there's any questions or comments, please. Yeah, you are like hardcore on all those Udemy things. We get free Udemy too at work, so that's been super helpful.
Jessica, just thanks so much. Thanks so much for coordinating this. I mean, we wouldn't be here without you. And yeah, and I really appreciate everybody else joining in, because it would be really boring if it was just, it's so much more interesting when we have more people providing resources and giving suggestions, and it feels more like a team effort. So yay. I'm glad we made it to this point.
I hope so. Yeah, I try to balance like the balance between like kind of leading a study group and like full on teaching, which is like a next level sort of situation. So Yeah, I hope it was a good balance. I hope it was worth it, or at least get people motivated to be prepared and kind of, because everybody studies differently. And I would just say, in the words of Ted Lasso, be curious, not judgmental. So yeah. And if you don't know who Ted Lasso is, you should. Thanks, Freddie. Yeah. So again, stay in Slack and let me know. And again, be in touch with me. I'm going to monitor the badge situation. But please also just, if you're going through badges and you're really aiming to push and like get to the end, keep me posted too, in case something is wrong with the tracker and I'm not seeing it. Yeah. So anyway, I'm going to let everybody go. And if you don't see the resources tonight, I'll have everything posted tomorrow. Awesome sauce. Thank you, everyone. I appreciate y'all and good luck.